we're going to start taking a look at being able to work a little bit with some basic angles in these videos. So in this example, we're going to start with degree measure. So for each angle given in degrees, we want to classify the angle as acute, right, or obtuse, or straight. Convert the angle to radians, draw the angle in standard position, and then also name the quadrant. And then finally, name two angles that are coterminal to the given angle in degree measure. So recall that any angle that's between 90 and 180 degrees is known as an obtuse angle. All right, so this one right here for letter A is obtuse. And we could just go back to our definition in the previous video and remember anything that's between 90 and 180 is obtuse. All right, so it's easy enough. Convert the angle to radian measure. So what we're going to do is we're going to take the 120 degrees and we're going to multiply that by pi over 180 degrees. All right, so remember, we have the relationship that pi radians is equal to 180 degrees, and we're going to put the pi on top and the 180 degrees in the denominator. And anytime we want to eliminate degrees, we should have degrees in the denominator. Anytime we want to eliminate radians, we should have radians in the denominator. A way to be able to simplify this is to use your calculator. And so all you're going to do is you're going to go in your calculator, you're going to type in 120 over 180. And then if you just hit the fraction, it converts to 2/3, but it doesn't have the pi in the numerator. Okay, so when you write these, you have to make sure that you simplify with the pi in the numerator. So this is 2 pi thirds in radians. In a graphing calculator, such as a TI-89, what you would do is you would type in 120 over 180, hit enter, and then hit math, and then enter and enter. All right, and that'll work to be able to change it into a fractional form. All right, so give that a try on your calculator. Maybe pause the video, give that a try. Make sure you can do that because we are going to be doing that a lot throughout these videos. For letter C, we're going to graph the angle in standard position. Now, remember, 120 is a little bit bigger than 90. All right, so in standard position, we start on the positive x-axis. And from here to here is a 90-degree measure. All right, but we don't want 90, we want 120. And so we're going to go a little bit further into here, and this will be the terminal ray. All right, so the initial ray is the x-axis, always in standard position. And then the terminal ray is just going to be wherever we end. Okay, so this is going to be, let's call this theta, which is 120 degrees, right? And we know theta is going to terminate in quadrant 2. Okay, so remember the quadrants 1, 2, 3, and 4. The last part is probably the easiest part of everything. Name two coterminal angles. Remember, coterminal means that they share the same terminal ray. And so for part D, one way that we can do this is to take the initial angle theta, which is 120, and we can add 360 degrees. And that's going to be 480 degrees. Another coterminal angle is to subtract 360 degrees, which is going to be negative 240 degrees. This trick always works to find a coterminal angle. Add 360 and then subtract 360. And what's happening with that is if we add 360, and this is going to be the initial angle, what happens is we just go around twice, okay? So this would be theta equals 480, right? And then negative 240, if this is the terminal angle, that just goes around this way, okay? So this would be theta equals negative 240 degrees, all right? So just seeing what those look like on our coterminal angles. They still share the same terminal ray, but in standard position, they just go either around one more time or they just go clockwise instead of counterclockwise for the negative. All right, theta equals 15 degrees. So this is going to be an acute angle. All right, remember anything between 90 and or 0 and 90 degrees is going to be called an acute angle. Right? Letter B, convert this into radians. We take 15 degrees. We're going to multiply that by pi over 180 degrees. Once again, in our calculator, we're going to type 15 out of 180. And then we could just hit the fraction button. it'll be 1/12, but it'll be pi over 12. So it'll really be 1 pi over 12. All right, so that'd be 1 pi over 12, otherwise known as pi 12ths. And remember, in your calculator, you just type 15 over 180, and then hit enter, and then hit math, and then enter twice. And that should give you the 1/12 out of that. All right, it's up to us to make sure that we remember the pi. 15 degrees in standard position, pretty easy. Just a little bit from the positive x-axis, so this might be 15 degrees right here. All right, I'm going to draw a little bit more. All right, so that's about 15 degrees is equal to theta. All right, in standard position. This is our terminal. This is our initial ray. Right? Finally, we know that it ends, for this part, it ends in quadrant 1. If I want two coterminal angles, I take 15 degrees and add 360, and that's going to give us 375. And then if I want another coterminal angle, I would subtract 360 degrees. That would be negative 345 degrees. All right, so those are two coterminal angles. All right, 375 would be this angle where you go all the way around once and it ends there. So that would be theta equals 375. And then if I want negative 345, that would be this angle. All right, so that would be theta equals negative 345 degrees. All right. Now, what if we want to go the other way? What if we're given the radian measure and we want to do all the same things, but this time we're going to convert into degrees, but we're going to make sure that we go through and try to go backwards from this. All right, so it might be easier for us to start with letter B to convert the angle into degree measure. All right, so here's how we're going to do that. We're going to take the pi over 4, and we're going to multiply that by 180 over pi. All right, and this is letter B. All right, and I know we're doing this backwards, but it's probably the easiest way. And we're going to say that's 180 degrees. The pi's will cancel out. We're left with 180 degrees over 4. And that should work out to be 45 degrees. But again, we can just use our calculators just to verify. So if I take 180 divided by 4, and that's going to give us 45 degrees. Now that's going to help us, all right, because what we can do is we can give letter A a little bit easier, and we could say that it's an acute angle. All right, so remember, any angle that's between 0 and 90 degrees is an acute angle. If we want to give the exact measure or approximate it, we could take pi fourths and stick that into our calculators, all right, accurate to 2 decimal places. And so in our scientific calculator, we would just type in pi over 4. That gives us 0.79785. So if we were around that to 2 decimal places, that's 0.79. If we want to plot the angle in standard position, we know it's 45 degrees. All right, so that's pretty easy. All right, so we plot it. At 45 degrees is halfway between 90 and 0. All right, so that's our terminal, that's our initial ray. This is theta equals pi fourths, which is 45 degrees. Right? We know that that ends up in quadrant 1. Right, so that's not that big of a deal. And then the last part says find two angles that are coterminal given in radian measure. All right, so here's the way we're going to do that. We're going to take our pi fourths and we're going to add 2 pi. All right, now think of 2 pi as 2 pi over 1. And what we can do from here is we can get a common denominator of 4. All right, so pi over 4 plus 2 pi over 1. And we're going to multiply the numerator and the denominator by 4 to get a common denominator. That's the same as pi over 4 plus 8 pi over 4. And then now we can add these together to get 9 pi fourths. All right, so that's one of the coterminal angles. To get the other, we do the exact same thing except subtract 2 pi. And again, think of 2 pi as 2 pi over 1. That would be the same thing as we got a common denominator of 4. So that would be 2 pi over 1 times 4 over 4. That's the same as pi fourths minus 8 pi over 4. All right, so it's the same thing as right here, except we just get a minus sign. And when we subtract pi minus 8 pi is negative 7 pi over 4. So that's how we can kind of keep this in the radian measure, all right, just by adding and subtracting 2 pi, which is the same thing as 360. If we have 11 pi 6, we can do the exact same thing, all right? So let's start with letter B, where we convert it into degree mode, all right? So this is going to be 11 pi over 6 times 180 degrees over pi. The pi's will cancel out. And what we can do is we could just stick this in our calculators as 11 pi. So we're going to say 11 times 180 divided by, or sorry, 11 times, if we go back, sorry, I forgot what it was, 11 times 180 divided by 6. All right, so, wrong one. So 11 times 180 divided by 6, and that gives us 330. Okay, so remember, that's the degree measure for this. Okay, so that would be 330 degrees. All right, now it's 330, and so going back to our original part, A, it's not acute, nor is it right, nor is it going to be obtuse. Okay, so it's not right or acute, obtuse, or straight. Okay, it just goes outside of those. Okay, so it's none of those. Another thing that it asks us to do is to give the approximation. So 11 pi over 6, and we're just going to go ahead and approximate that. Give the approximate radian value to 2 decimal places. And so in our calculator, we can go ahead and just type 11 pi over 6. So 11 pi gives 6. All right, that gives us 5.76 radians. Okay, that's an approximation. That's our conversion. Letter C, we want to plot this in standard position. Now, 330 degrees is almost 360 degrees. All right, so if I plot this, we're going to go almost all the way around. Okay, so just because it's a little bit less than 360 degrees. So theta is going to be 330 degrees, which is 11 pi 6. And that ends up in quadrant 4. Right, so that's important for us to remember. Last thing we're going to do is we're going to convert this back into radians to get coterminal angles. Okay, so remember, to get a coterminal angle, what we're going to do is we're going to add and subtract 2 pi. So first we're going to take 11 pi over 6 plus 2 pi. And remember, think of 2 pi over 1. What I'm going to do is I'm going to multiply the numerator and the denominator by 6 for that 2 pi to get a common denominator. Right? So that's going to turn into 11 pi 6 plus 12 pi 6, and that's going to turn into 23 pi 6. So that's one coterminal angle. And then another coterminal angle is when we take 11 pi over 6 minus 2 pi, and we're going to multiply that by 6 over 6, just like we did the previous. So that's going to be 11 pi over 6 minus 12 pi over 6. All right, so it's the same value as we just got. That's going to be negative pi 6. All right, so those are our two coterminal angles in radian measure. Okay, so hopefully that helps to be able to see how we can take these angles in both radian degree mode, try to convert them, be able to plot them in standard position, how to work with some of the definitions of those. Okay, so our next videos, we're going to take a little bit more in-depth look at some of these angles, and we're also going to start taking a look at arc length as well as linear as well as angular velocities.